Okay, you're going to need to know what some new things about angles. Angles in standard position first. We're not talking about the radians yet. Angles in standard position is an angle. Well, angles are determined by two rays. You guys know what, you've seen this before, an angle. Okay, and an angle is an opening between two rays, and it's measured in degrees. Okay, that opening. You don't have to write that down if you don't need to. That's just reminding you what an angle is. Okay, the degree measure of an angle in standard position is described by the amount and direction of rotation from the initial side to the terminal side. Now, in geometry, you talked about angles only, well, mainly under 180, but you did talk about some things that went up to 360, right? Most of your angles, those angles that you measured, they were all 180 or less. Okay, so they were obtuse, acute, right, or straight. Now, we're going to learn about angles that go beyond that. Okay, so an angle is described by in standard position, describe the amount and direction of the rotation from the initial side, which lies along the positive x-axis, to the terminal side. The terminal side, in this case here, is right there. The initial side, again, is going to be your positive x-axis. Okay, so we're starting there. That's the initial side as it's labeled. And then this angle is going around until it hits its terminal side, which is where it ends. Now, clearly, that angle is over 180. So now we're going to be talking about angles that are larger than 180. If you're going counterclockwise, a counterclockwise rotation is associated with a positive angle. So this would be going in the positive direction. If we were to go this from the initial side in this direction, that would be a negative angle. Okay, so clockwise rotation from the positive x-axis downward, that is considered a negative angle. Clockwise is negative. Two or more angles in standard position with the same terminal side are called coterminal angles. Now, coterminal, I'll show you a picture of some coterminal angles. So say you had an angle that was positive 90. Okay, so that's positive 90. What would be coterminal with it? That's a negative angle. Well, it would be going that way instead, and it would be going to here, which would be 90 plus 90 plus 90, so it would be negative 270. Okay, those are coterminal. They're terminating at that same spot. Okay, the terminal side would both be for them that ray, and their initial side was both the positive x-axis. One angle was positive, one angle was negative. Okay, those are called coterminal. Now, how do I get? You can get it by doing 90 minus 360, and that's negative 270. Okay, so those are coterminal angles. Now, draw an angle with a given measure in standard position. So we would draw this angle, of course, the first initial side, and I'm not going to keep writing this. This would be your initial side. You would go in the positive direction. Now, what are you hitting when you get to here? Now, here was 90. This was 180. We're going past it how much to get into here? So this would be terminating in quadrant 3. This is the terminal side. How far in are we? 30 degrees. Okay, this is 30 degrees, and that would be called your reference angle. I'm going to go ahead and tell you some stuff early on about reference angles, because I think it's an easy time to talk about it to estimate how far in we were supposed to go. So in the next one, I'll tell you what a reference angle is right now. So you can make a little sketch here. Make yourself a decent size T. And I'm going to make on that something I call the bow tie. The bow tie is where the reference angles are. Okay, so in the quadrant 1, your reference angle, this is your reference angle. In the quadrant 2, your reference angle is going to be here. Quadrant 3, it's going to be this number. And in quadrant 4, it's that one. So it kind of makes a little decorative bow tie. All right, so let's try the next one. We got positive 305 degrees. So we're going to come from the initial positive x-axis. I'm not going to keep writing initial side, etc. Come all the way around past. See, it went 180. What's going to be the next quadrant? What's straight down? 90, 90, 90, 270. So we got to go past that, right? All right, now we're into here for my 305. I don't know why my thing went flat right there, but I just didn't make a very nice curve. What is this angle where the bow tie is? Yeah, 55. Reference angle, 55 degrees. But it takes 55 more degrees to get back to the x-axis, which is full 360. Okay. All right, 580. Oh, gosh, that's positive. So we're going to have to go around once. And then let's go ahead and subtract 360 and see how much further we've got to go. So 580 minus 360 is 220, right? So we've got to keep going around past the 180 again. How many degrees? 220 would be how far into the third quadrant? 40 degrees, yep. So that'd be 40 degrees for your reference angle. I know, so we're going to go way past the 360s now sometimes. Okay, 135, positive. We're going to go past 90. How far? Okay, so we're in 45. So how much is left to get back to 180? The bow tie number would be 45. That would be a reference angle, 45. Okay, drawing a negative 450. We're going to go around once, and then I'm going to say, all right, let's add 360 here and see how much further we have to go. Negative 450 plus 360. And that's, I'm doing that because it wouldn't help to subtract 360. Do you see what I'm saying? I'm going to add 360 now, and that's going to give me negative 1. Oh, no, negative 90, isn't it? Okay, so that means I got to go back. All right, I went around negative 360, and then I got to keep going to 90. So I want you to talk about this one. That's 90 degrees. Oh, I went the wrong way. I went, where did I go clockwise? I was supposed to go, I went counterclockwise. I was supposed to go clockwise. I was looking at thinking, why am I not going in a negative direction when I started to think about where I'm going to end up? Poopy. Sorry about that, guys. My bad. Negative 360 and then another negative 90. I was thinking, I got to be down. Why am I not going there? All right. All right, that's where we are. And now I want you to note that this is negative 90 degrees or positive 270, which is a quadrantal angle. Quadrantal. Anytime you hit one of the quadrants, which would be an angle that is terminating on the X or Y axis, it's a quadrantal angle. So obviously they're going to be 90, 180, 270, 360, or 0. All right, negative 560, I'm going to go the correct direction, please. Down and around, and then I'm going to finish by adding 360 and deciding how much more I need to go. Maybe negative 200. So I'm going to have to go in a little bit past negative 180. So I'm in here. How much is my reference angle? Okay, so I had to go 20 degrees in, right? Or 20 degrees above. Oh, right there. I don't, what? Oh, say that again. An arrow what? I couldn't squeeze it in here. No, please tell me. What? Oh, why didn't I draw it here? This one? Because it's right on an axis. Okay, its terminal side is that ray. That's it. Yep, I got it. I know what you're saying now. That's the terminal side. And that's why it's called a quadrantal, because it terminates right on one of the quadrants. Okay? No, I'm glad you asked me that and clarify it. You mean the final? Well, it's there, isn't it? I could highlight it. It's going to be there. I showed that I stopped there by my arrow stopping. Right? Is that okay? We can highlight it. Is that better? Do you know why it stopped there? Why I didn't draw? Right. It went, I made that ray. Got it. It's because it's right there, and it was a quadrantal. That's the only reason. Okay? All right, find an angle with a positive measure and an angle with a negative measure that are coterminal with 250. The way you do that is you add or subtract 360. Okay. We take 65 plus or minus 360. Nick, this is worksheet 12, A and B. Okay, 65 plus 360 is going to be 425 degrees. 65 plus or minus 360 would be negative 295. Okay, so one of them one's a positive coterminal, one's negative coterminal. Oh, I don't care where they go. I'll separate them with, no, I actually earlier did it like this. Okay, we have had to pause. It's up to you. All right, this would be 400 and, okay, 45. Did I not add? No, 80 plus 365. I can't. Oh, it's a 360 because I'm getting so distracted. So 440 degrees. All right, and then minus would be negative 280. Okay, 110 plus 360, that would give us, and now maybe if I separate them, you'll feel better, 470. 110 minus 360 is going to be negative 250. All right. Okay, I'm going to talk to you momentarily about radians. Please just look up here for a moment. In a circle with radius of r, that would be your radius. This is something about a picture that you have on your paper, but I'm going to explain a little bit more. The concept of radians is that a radian, one radian, is the length of an arc on the circle that is equal to the radius of the circle. So that's the same length as r right here. Okay, and it's the length of that chunk that's a curve. You remember in geometry, you did arc length. Okay, it was measure of the angle, central angle divided by 360 times the circumference of the circle. Yep, you did that. I know you remember. All right, so that is representing 1 radian. Now, I didn't necessarily draw that perfectly, so bear with me. A circle is, well, if it has a radius of 1, what would its circumference be? Circumference is 2 pi r, right? Okay, now, if I want to know if I put in a radius of 1, then it would be the circumference of the circle would just be 2 pi, agreed? Yes. Okay, now, if I want to solve, let's say I'm talking about Degrees. I'm not going to tell you what this angle is right yet. I'm going to tell you that a radian is a degree measure, but it's in a different form. Okay, it's a measure of an angle, but in a different form called radians. So let's compare it. I'm going to show you how we're going to figure out how big that angle is. So circumference, what's that got to do with? The distance? All right, and if we're talking about degrees, what could we trade that for in degrees? Okay, so then if I divided by 2, I'd get 180, right? So I'm going to put on here now, we're going to be learning the unit circles starting on Monday. No, I'm going to teach you how to do it. Don't worry, it's a pattern thing. You'll be all right. It's not so much about shapes. Okay. Now, when I get to here, this is 180 degrees. Agreed? Straight across? Okay. How many radians is it? This is actually pi radians equals 180 degrees. Okay. So I just told you that 360 is pi. Okay. 360 degrees if you're going around. This is pi in radians. Now that's the beginning of generating the unit circle. Okay. Unit circle meaning a radius of 1. Okay. Now you already know about 90, but I don't even want to talk about that right now. Okay. So I'm going to talk to you about what a radian is. I'm going to continue. Now if I took this and I divided both sides by pi, I would have 180 over pi equals 1 what? Radian. All right, on your calculator, type 180 divided by pi. No, the actual pi button. It's above the arrow up key, or the caret key, yeah. So 180 divided by pi, you should be getting about 57.3 degrees, right? Okay, so basically, if I keep, well, not basically, if I kept our drawing, this was 1 radian right here, and I kept going around, it's not actually going to be a full 3 to get to there, is it? What's 3 times 57.3? So it's not quite getting to 180, you follow me? So this is like, what I want to explain to you before I tell you about what we're going to do conversions for radians. This is a radian. That's 1 radian. This would be, then when we get to here, we'd be at 2 radians, right? This would be, we got here, that would be another radian. That'd be 3 radians, which is about what you guys just calculated, 171 something degrees, okay? So the number of radians is actually 2 pi radians all the way around the circle. So if you did 2 pi on your calculator, you're going to get 6.28 blah, 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 blah. All right. So there's actually 6.28 radians to get around the circle. Does that, you feel it? So it's how many lengths of this that takes to get around there, actually. Okay, now, pi is generated by doing the circumference of the circle divided by the diameter. That is what pi is. It's any circle's circumference divided by its diameter. Okay, now quickly here. These are ones that you're going to want to memorize. No, you will end up knowing everything on here and more. Don't worry, I'm going to show you how to learn it. It's not that bad. Quizzes for the unit circle tests usually are almost all A's. I'm telling you. Most of you will get a perfect score because you will know I will teach you how to get it memorized. It's not that hard. There's a lot of patterns in it, and it's really not hard. Okay, so we will start looking at that Monday. Today, we're kind of getting a peek at it. This is what I was just drawing for you guys, okay? I kind of was showing you what a radian is. It's a radius. We're going to learn to convert. 30 degrees is pi over 6 radians, 45 degrees, pi over 4 radians, 60 degrees, pi over 3, and 90 is pi over 2. Do you see any pattern already? 6, 4, 3, 2, it's always going to go that way. All right, and so this will be, we'll figure out how to generate that. Okay, so I already explained this whole thing. 2 pi radians is 360 degrees, pi radians is 180, and I actually showed you what 1 radian was equal to in degrees. So let's move. If you'd like to write down a couple of those things that I just demonstrated with you, I'll show you what I was talking about just a moment ago. Again, circumference of a circle is 2 pi times the radius. If r was equal to 1, then the circumference would be 2 pi times 1, or just 2 pi. If we replace 360 for the circumference, replace that into degrees, that would be 360 degrees equals 2 pi radians. And then we divided it out and got 180 is equal to pi, 180 degrees equals pi. And then we divided and we said, oh, then 180 divided by pi would equal 1. And that was how we got about 57.3 degrees for 1 radian. So I wanted to show it to you before you had to write it down and make you think about it as I was doing it. All right, now gradient and degree measure. We're going to learn to convert. So the conversion, let's think about this, is either 180 over pi or pi over 180. All you have to do is remember that and then say, well, if I want to get rid of degrees and if I'm doing the dimensional analysis, where would degrees need to be for it to cancel out? Right, so that's why you would use the one that has 180 on the bottom and pi on the top. I hope that makes sense. If you want your degrees to cancel, 18 goes into 180 how many times? Yeah, so I can go 18 into 180 goes 10 times. My answer is pi over 10. And that's now in radians. No, I want you to leave it like that. No decimals, okay? We're going to do them if, okay, well, here's going to be the deal. If your answer is in degrees and you're converting to radians, you're going to leave it in terms of pi. If your answer is in radians and you're going to turn it degrees, then you don't have a pi anymore. Okay, so this one, we're going to multiply by pi over 180. 6 goes into 180 30 times. So you can do it without a calculator, or you can actually use the calculator, which I'll show you in a moment. Pi over 30 radians would be the answer to that. And normally, you do not have to write radians behind your pi over 30. So I'm going to stop doing that. Negative 72 times pi over 180. I'm going to use my calculator to help me out with that one. I'm going to hit negative 72 divided by 180. And I'm going to hit math, enter, enter. Negative 2/5 is what I get. What we're saying, well, what happened to the pi? Don't put it in the calculator. Then your calculator can do the fraction reduction for you. Okay, so you only want to type that in numbers. And I got negative 2/5, and then I put pi on it. Negative 2 pi over 5 would be the answer now in radians. Multiply this one by pi over 180. Go negative 820 divided by 180 if you don't want to do it by hand. Math, enter, enter. Get the reduced fraction of negative 41/9. I don't remember doing that second hour. A negative 41 pi over 9. Good. All right. Now we're going to convert from radians back to degrees. So 4 pi radians, it's going to be under 360 because remember it was 6.28 radians to get around. All right, so we're going to multiply. Oh, actually, this is going to be more than, it's going to be twice around. If 2 pi is 360, it's going to be 720, isn't it? Okay, let's check it out. So the conversion factor is 180 degrees over pi. 4 times pi is actually bigger than 6.28. Don't know what I was saying in the beginning. The pi's cancel out, and we're just going to have 4 times 180, which is 720. Okay, multiply by 180 degrees divided by pi. The pi's cancel. I can do 2 goes into 180, 90 times. And I can do just 5 times 90 and get 450 degrees. Next one, multiply by 180 over pi. Cancel out, 2 goes into 180, 90 times. Pi goes into pi, and then you'll have negative 9 times 90, negative 810 degrees. And the last one, 180 degrees over pi. Cancel out. I think I'm just going to type that one. So I'll just go -7. Was it 12? Oops. I don't know where I got 17 there. -7 divided by 12 times 180. Only put in the numbers, not the pi. Second, oh, not second, math. Enter, enter. Oh, I did something goofy. All right, guys, what'd you reduce it to? Because you've already got it done. Is it -105? That's all we need. I'm just waiting. You've probably already calculated it. Any problems or any questions up through here? All right, find an angle with a positive measure and an angle with a negative measure that's coterminal with each angle. Uh-oh, they're in radians. Guess what? Your answers have to be in radians. Do not convert to degrees. So since we've talked about coterminal angles, adding or subtracting 360, what do we have to do if it's in radians? We're going to add or subtract radians for 360. What was radians for 360? Once all the way around the circle is how many radians? Well, it was 6.28, but where did that come from? 2 times pi, okay? You're going to add or subtract 2 pi. 2 pi is once around the circle in radians. So add 2 pi. I'm going to show you how to do this. And part of the reason we've done rational functions, we've talked about fractions. You think of this as being over 1. You would multiply the top and the bottom to get a common denominator of 5 by 5. Okay, that's going to give us, and I know it's plus or minus, so I'm going to just write this all at once, and we'll talk about 2 pi over 5 plus or minus 10 pi over 5. 2 pi over 5 plus 10 pi over 5 would be 12 pi over 5. And the other one, 2 pi over 5 minus 10 pi over 5. 2 minus 10 would be negative 8 pi over 5. Five pi over 6. We need to add and subtract 2 pi. Get the common denominator would be 6. Multiply 2 pi by 6 over 6. So I've got 5 pi over 6 plus or minus 12 pi over 6. 5 pi over 6 plus 12 pi over 6 is 17 pi over 6 for the positive angle. 5 pi minus 12 pi would be negative 7 pi over 6 for your negative angle. When you add and subtract fractions, the denominator must match, and then it remains the same once you add and subtract. Okay, negative 3 pi over 2 plus or minus 2 pi. Again, multiply top and bottom by 2 to get the common denominator of 2. That's going to give you negative 3 pi over 2 plus or minus 4 pi over 2. Negative 3 pi over 2 plus 4 pi over 2 will be 1 pi over 2, or just pi over 2. And the negative answer, negative 3 pi over 2 minus 4 pi over 2, would be negative 7 pi over 2. Okay, I just showed all the steps, so I think wasn't too bad. Okay. So if it's in radians, your answer needs to be in the same units. If you're doing degrees, coterminals, they have to both be in degrees. Now we're going to do a new formula. You will be given formulas. You will have a formula sheet for the final test in this unit. Once we even test memorization of this unit circle, you will then get to use a unit circle to go further with the concepts that we use it for. Okay. Arc length. Arc length is S. S stands for arc length. The length of an arc is the measure of that piece of the circumference of a circle. Back when you were in geometry, you did 360, or the measure of the angle measure divided by 360 times pi times the diameter, or 2 pi r. That was what you did in geometry. to find that little angle. Now we're going to do it in radians. So the formula has changed. You're not using that formula. You're going to use S equals R theta. S standing again for arc length. And R, of course, is your radius. And theta is the angle in radians. It has to be in radians. Degree formula is back to geometry where you do angle measure divided by 360 times diameter times pi. All right, so these are really simple because some of these are already in radians. This is theta in radians, okay? Since it's given in radians, you don't have to do any conversion. You just type 3.5 the radius times pi over 2, and we're going to get a decimal. I'm not requiring, you don't have to have like fractional answers or something here. Okay, so, oh, I don't know why I wrote 2.5. It's supposed to be 3.5. Do you have a pass? I need to see it. 3.5 times pi. You have to hit the sec t divided by 2. And that's 5.5. Thank you. 5.5 what? Did you have to sit and wait? 5.5, and this is just in units. I didn't get given anything. Unit labeling in this chapter is critical. Proper labels are really important. So I'm going to be real picky about labels. It should have said maybe inches or something. You would have flat inches because we're going to be doing area as well. So we have to know when it's square, when it's not, when it's, you know, what the proper labels are. All right, go for this one. You're just going to type away 4.25 times 3 pi over 2. And this one will be 5.62 times 5 pi over 3. Okay, you guys type them and then I'll just check and see if you got the correct answer. Okay, number 22, you should have got 20.0 units. Any problems? Okay, type out number 23, please. You guys tell me what you're getting? What, Caitlin? Oh, I thought you were raising your hand. Sorry. 29.4? All right, let's move on. Now, we're almost to the end. We just have 2 more questions. Find both the degree and radian measures of the angle through which the hour hand on a clock rotates. And I know you're going, well, Heimer, all I have is a digital watch. No. A lot of you don't use, and you just go looking in the corner of your computer, or you look at your phone. It tells you the time. Okay. Will you check your mode, please? Degrees. Okay. Try typing it again. 5 point. Okay. Let me just. I'll type it at the same time. 5.62 times 5 pi. 5. Hit the second button and the arrow up to get your pi. Divided by 3. Got it now? I'll try to come over and look in a minute. We got it now. All right, so let's talk about the clock for a moment because you need to be able to figure this out. Find both the degree and radian measures of the angles through which the hour hand on a clock rotates from 5 a.m. to 10 p.m. How many numbers are on the clock? Right, thank goodness you know that part. You got 12 numbers on the clock, right? All right. You got 1, 2, 3, 4, 5, and then straight down is 6. And then you got the others, this 9 over here, and then there's 2 in there that are 7 and 8. Okay, so yeah, I want you to know how to do this. 10, 11, and then you know up here is 12. Okay? Good enough? How many spaces are there throughout that round clock? Why are clocks round? Well, there is a reason. It has something to do with circular motion, etc. Okay? That's why you don't really know much about or don't think about this much because of what you've been looking at now to tell time anymore. You're not really doing, we do have analogs in here. Okay, there are 60 minutes in there. Those represent the hours. So let's figure out if we're going from 10 a.m. to 5 a.m. to 10 p.m. We're going from here. We have to go all the way around to here, which is how many hours? 12, 13, 14, 15, 16, 17 hours have passed. All right, that's 17 hours. You're going to have to know this for this unit, all right? And we kind of just should in general. Now, how many degrees is each hour hand turned? What's the whole circle? How many pieces are there? All right, so it's 30 degrees each hour, right? Hour hand moving, each hour hand, each time it moves an hour, the hour hand has gone 30 degrees. So we got to do 17 times 30. That's 510 degrees. Okay, now we're going to convert that to radians. So let's do the conversion factor. Otherwise, we would say, okay, 2 pi plus, and that'd be a pain. All right, so let's go 510 times pi over 180 because we want to get rid of degrees. 180 goes on the bottom. And then you can start typing on your calculator the fraction 510 divided by 180. And then give me it in terms of pi, please. All right, so 17 pi over 6 in radians, or if you wanted to tell me in degrees, go ahead and hit enter again. I think on your calculator, it'll probably give it back to you in degrees. It's like 3,323 degrees. You guys got 17 pi. Wait. I don't know what I'm looking at the next question. This is done. We need the next question. Hello. I'm looking at the next question. I'm like, why do I have that written down there? A truck with a 16-inch. I'm ready to do the truck problem. All right, we got a truck. It's got a wheel. It has a radius of 16 inches. All right, so let's jot down what we got. A radius with 16 inches in it. And it's driven at 77 feet per second, or 52.5 miles an hour. Ignore that part. Find the measure of the angle through which a point on the outside of the wheel travels each second. Round to the nearest degree and nearest radian. Well, I got a little issue with the fact that my radius is in inches and my speed is in feet. So let's multiply this by, there's 12 inches in a foot. Okay, so I'm converting it. I'm showing you dimensional analysis because we're going to need to know how to do it in this unit. A lot of you have already done dimensional analysis in your chem or in your science class. All right, feet cancels out with feet. Now I got 77 times 12, which is 924 inches a second. Okay, 924 inches per second is the speed. Now it says round to the nearest degree and nearest radian. This is inches per second. This is actually going to stand for, well, let's put it in the formula. What's S equals R theta? That's our formula that we know about the length or distance around that outside of that wheel. Okay, do we have anything? Yeah, so we got 16 inches for R. We're trying to find theta, and we know the distance around, we went to 924 inches every second. So we'll put 924 inches in here. Because it's actually asking us to find out how much it travels each second. Okay, so what are we going to do? We're going to divide the 924 inches by the 16 inches. And that's going to give us theta, which is what they asked us for. All right, the inches cancels out with inches. I just keep showing the dimensional analysis. And 924 divided by 16, I got about 58. You got 57.75, but it said round to the nearest degree and nearest radian. So that would be 58 radians because this formula gives us our theta in radians. Now let's convert the 58 radians to degrees. All right, so 58 times 180 over pi. So I'm going to do 58 times 180. And then hit divided by pi. And remember, pi's in that second arrow up, and you'll get pi. 3,323 degrees. Okay, you've got your book page printed out for you. I expect you to work on that and talk to me about some things on Monday. If you'd like to use highlighters on Monday, we're going to have, you'll want, say, 3 colors, because there's 3 reference angles, and maybe you just have a dark or a black for the quadrantals. 3 or 4 colors is what I'm telling you if you'd like to do highlighting on Monday.